Okay, this is 12.6, the direct current motor. Now, a motor is something that moves continuously when you send electricity through it. And nowadays we have motors all over the place, but before 1821, before Faraday did his experiment with the motor principle, well, they didn't have anything like that. And so scientists were trying to come up with a way to get some continuous motion out of electricity, and it was a really exciting thing to explore. They knew it had to be possible because they had started having wires move when they send current through them in a magnetic field. They had found all these cool little things happening. Their goal is continuous motion. So I'm going to say here, it would be cool. This is what all the scientists were thinking then. It would be cool to build something that could spin continuously with a current. And of course, that would be a motor. So it would be really cool to be able to make something like that. And they were trying to figure out how they could do that. The closest thing we have so far is a galvanometer, which we learned in the last lesson. The galvanometer was this thing, we have a picture of it below. This thing where we've got a loop of wire, or a coil of wire, and the magnetic field that it's in causes it to spin. So this field causes this wire to spin that way, that wire to spin that way. But unfortunately, once that wire gets to sort of this top point, and this wire gets to that bottom point, well, that magnetic field is going to force this wire up, this wire straight down, and it's sort of stuck then at that point because these two are connected. So if one's being forced up, one's being forced down, it doesn't really help. It's pulling it apart, but it's not actually going to make it twist anymore. So it stops twisting at that point. And even if we could push it further around, if we could keep going this way a bit, well, you see that still we've got a force pulling this down, a force pulling this up, and they're going to want to try to go back in this direction, back to that vertical point. So that vertical point is sort of a stopping point. It's a bit of a problem if we want to make something that's going to spin continuously. So we'll say about the galvanometer here, the spring, well, this is another thing, is that this arm here has a spring attached to it. So the spring stops it from moving. The spring stops it from moving too far. We didn't really talk about that, but that's one problem. But really the bigger problem is what I was just describing below. Even if it could move more, the forces would stop. The forces would stop when the coil was vertical. When the coil is vertical. I'll just say C below. That's what we just talked about. So that once these wires get into this sort of central position, vertical position here, they get sort of locked there. They don't want to move one way or another. That's their preferred location, I guess. So that's a bit of a problem. Somebody came up with a really good idea called the split ring commutator, and that's the picture that we have right here. That's our split ring commutator. And if you take a look at that, we still have our loop of wire like this, just like we do in our galvanometer. We have our magnetic field like this, and that loop of wire is attached. I'll just undo a few of the arrows I've drawn here. You can see that that loop of wire is attached to this big spherical thing and this, I guess, cylindrical thing, and this cylindrical thing. You see they're both sort of half cylinders, and they're split apart so that there's nothing in the middle here. There's just air. So the way this works is that on the left here, this guy, this is called half of the split ring commutator. You can see that together they are the split ring commutator, which makes sense because it's like a ring split in half. So this left one is touching this brush here. We call this a brush. It's like imagine a metallic brush, so a bunch of fibers or hairs that are brushing up against there. But it can move relative to the ring. So right now this one's in contact with that bunch of brush. So that metal goes through here. So you can see that our positive terminal is here. So really, if we're drawing our current, we go from positive down the wire, through the brush, into the split ring commutator, down the wire here, around, 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 into the other commutator, into the brush, and back down this way. So that's what's happening here. But the cool thing is that as my ring rotates this way, because that's the direction it's going to want to rotate, I think, hang on, let me just make sure that that makes sense here. And we can check by saying I have a current going this way, magnetic force going this way. So I put my thumb, my hand. So actually this side is going to want to go down, and the other side is going to want to go up. So I was wrong. It's opposite. Okay, so here we go. Our loop wants to twist this way, in this case. And at a certain point, you can see that this ring is also going to rotate that way. At a certain point, you're going to see that this gap lines up with the brushes. So that then the brushes aren't actually touching anything. This gap lines up with that brush. Which solves our problem of that vertical position there. This vertical position that is such a problem. Once it gets into that position, the connection breaks, and then it goes a bit past, and the other ring connects, and so it's able to keep on spinning. So we'll see a bit more of that in the pictures below. But this is our split ring commutator. So the idea here is the coil is connected to the battery by brushes. Brushes that are touching a split ring commutator. When the coil is vertical, the connection breaks then it reconnects to the other side to keep going. And I think that's pretty cool. It's a really clever idea, and it solves the problem. It is what still a lot of our motors are based on this principle here. It's a really, really useful idea. So we'll take another look at what's going on here. Now we've got our split ring commutator in 4 positions. So you can see that here if we follow our current is going like this, through this ring, that ring, like this. And it means that we're going to get our commutator, or sorry, our loop here, to be going around in a rotation like this. So you can see that it's still rotating like that in the next picture. We can follow our current. It's still the same picture. It goes into the purple here, the dark one, back up into the pink, and back through. Okay, it's rotating, but you can see that it's getting closer to this gap. So that now it's rotated a bit more. It's still rotating this way. It's rotated that bit more so that now our current can't actually go anywhere. I've drawn that. Really, there would be no current running through in this case because it's not a complete circuit. The current has nowhere to go. It's not touching there. And so I'll draw like a bit of an X here because the current can't go. But then it goes a bit further. Just by momentum, it keeps on spinning, which means that now our current is going into this pink one. And it's going through like this, and into the purple, back into the brush here, and out this way. And that's our current. You can see that's going to make this thing still continue to rotate in that direction, the direction it was going. So it solves everything. It makes our motor just work. It's pretty amazing. That is a split ring commutator, and you're responsible for understanding how they work. Okay. On this second page, we're just expanding on the split ring commutator just a bit, taking that idea and seeing how it has been improved on a bit more recently. So the first improvement is called the Armature DC motor, and there are two improvements here. Two improvements to increase the magnetic field. And of course, increasing the magnetic field means that our motor is going to become more powerful. It's going to spin faster, it's going to be able to push out more torque, it's going to be a better motor. So these two improvements. The first one, we just put more loops on the inside. So on the previous page, we just saw a single loop. Now we're talking about having a whole coil instead, a whole coil of loops. Each loop increases the magnetic field that the motor experiences. So the more loops, the better. Number two, inside the loops, we put an iron core. And that's called an armature. That's why this is called an armature motor. And you can see a picture of those below. These first three pictures here, these ones, are all of the Armature DC motor. So you can see that we have the same basic idea. We have our coil of wires with a metal bit stuck inside, and all of that improves the power, the strength of the magnetic field. So you can see again, we have our core rotating this way, and rotating it this way. You can see that it still has sort of the gap there in its ring, so that gap will solve the problem of that vertical position. When that gap hits the vertical beams there, the connection will be broken. Okay, that's the Armature DC motor, and modern DC motors have just a couple other changes. So these have several coils and several splits. For two reasons. There's a picture down here of these modern DC motors. So you can see that each one of these little lines here, well, I'm not doing a great job of drawing those lines, but each one of those dark lines is a split in our commutator. So that there's actually, instead of just two pieces, there's, looks like maybe 20, 30, 40 pieces. And only two of those are ever going to be connected at once. So the reason for that, there's two reasons. One, the motor, in this case, is never in the incomplete circuit. The incomplete circuit state. And that's that vertical position where we're saying we're just going to disconnect it. With these modern DC motors, that can never happen, which is good because that means it can always start up. you can imagine with our old split ring commutators, if our connection just ended up in this point where here's our brushes and here's our rings, and it just stops like that where they're not touching, and then you try to turn your motor on, nothing's going to happen because the current can't go through. So modern DC motors have solved that problem. And another problem here, they maximizes force by using the optimal contacts. And I won't have you worry too much about what that means. I'll just say that that the force is maximized if in this position here, where the force is being applied at the extremes, the left and right, and it gets less and less and less as the force is being applied at the top and bottom here. I won't get into those details, that's fine, but that's one of the improvements that modern DC motors have made. Okay, so we've got one little problem here just to make sure we understand how this works. It says, in which direction will the following loop rotate? And what is the purpose of the split ring commutator? So we take a look at this one. It's the picture over here. We follow our current. So plus, plus, so we're following from plus. It's going into this brush, which is going into this end of the split ring commutator. It's going this way, this way, this way, and back through this brush. So what we need to do is check one of these wires, or check this loop in here. So if I check this side of the wire, well, there's my finger, or there's my thumb. That's the direction of my thumb. I look at my magnetic field. My magnetic field is going this way. So I do my right-hand rule. My thumb goes along the current, my fingers go in the direction of the magnetic field, and my palm is pointing downwards right now. It wants to move downwards. So that means that the force that I experience here is downwards on this wire. And likewise, if I do the same thing for that top one, it experiences a force upwards. So that means that it is rotating in this direction, which is clockwise. Okay, clockwise means the direction of a clock. So that's our answer here. It is rotating clockwise, CW. And I'll just make a little note in here. If you aren't aware, then you can, the other direction is counterclockwise. Which we call CCW. Okay, so CW and CCW, those are our two directions. Sorry, I'll just clean that up here. CCW. Okay. And what is the purpose of a split ring commutator? Well, our purpose here, there's two purposes. One, prevents the motor from getting locked in the vertical position. And two, it changes the direction of the current so that the motor keeps spinning in the same direction. There you go. So that's the lesson. That's the end of chapter 12, and I hope you enjoy it.